But thank you so much, everybody, for joining us for tonight's session. My name's Annalise. For some of you that have been coming to sessions, you recognize me probably. For those of you who are new, welcome. I'm a Learning and Development Coordinator at SWEHQ, and I've been moderating all of the SHLA sessions. You guys, today we have Ruby Lopez from Turner Construction, and she will be presenting a day in the life of an engineer. We are just really excited to have her here. Before I get too much into introductions, I just want to do a quick housekeeping reminders, just so you guys know, we are inching closer towards the end of this SHLA year. So make sure that you're getting your 4 sessions viewed and completing all of your post-session surveys. All of the links to those things are in that SHLA resource document. If for some reason you don't have access to that document, you can send an email to outreach@swe.org and I will get that sent over to you. And then after this session, there will be an optional discussion question posted in the Slack channel. I know not everybody has access to the Slack. We've been having some issues with that. So I apologize for that. Some kind of being not everybody being able to have access to that. If you're still having access issues, you can always send an email to outreach@swe.org, and whenever we're able to get things fixed, we will get you sent an invitation. And then Ruby, if you can go to the sponsors page. Yeah, quick shout out to all of our sponsors. We have Amateur Radio and Digital Communications, Danaher Corporation, General Motors, and a very special shout out to Turner Construction because they made this specific session possible tonight. And I just want to, guys, Ruby's so amazing. I've seen what this session is. It's just so interesting, and I feel like it's a little bit different from what you guys have been seeing up until this point. I think you're all really gonna like it. Ruby Lopez is our speaker tonight. She joined Turner Construction as a field engineer in 2014, and today she's a project engineer with experience on a variety of commercial healthcare projects. And she has a really, really phenomenal presentation for us today. So let's all give her a warm welcome, and I'm going to turn it over to Ruby.
Awesome. Thank you so much. I'm super excited to be here with everyone and to share a little bit of what I do. I hope I can inspire you to maybe follow on some of my footsteps, or at least to get into the STEM fields. It's a great career. Before we get too much into it, I do want to take a safety moment, as safety is a very important part of what I do every day here at Turner. So at this time, I want you guys to just take a second and just look around wherever you are, and make sure you identified means of egress. God forbid something happens. I want to make sure you guys are safe and know exactly how to exit the area you're in. So please take a moment and just look around. Okay, I've identified my exit strategy here, so I hope you did too. All right, thank you. And so with that, before I go too much into it too, can you guys put in the chat, what are some of the things that you guys think would be necessary or appropriate to wear or to have as a means of safety if you go to a construction project site? We call this PPE, personal protective equipment. Can you guys just throw it in the chat? And if you guys can chat it out, because I can't really read what the chat.
Hard hat, closed-toe shoes.
Yes.
Safety goggles.
Awesome. All right, safety goggles, vests, perhaps, right? High visibility vest.
No jewelry.
Okay, very good. Anything else? Anything different? I think you mentioned safety goggles, right?
Tie long hair back too.
Okay. Yes, believe it or not, I sometimes I have a long hair, and sometimes I have to put it in a ponytail or, make it a bond. So those are all good answers. Thank you. All right, so moving on. As it was mentioned, I graduated from Stevens Institute of Technology with a bachelor's and a master's of civil engineering. Stevens had this 5-year program where, I could take extra classes and graduate in 5 years with my bachelor's and master's. And so I was able to take advantage of that. So right after graduation, 2014, I entered with Turner, and I've been with Turner for about 8.5 years ever since. Some of the things I want to bring to your attention is, while in college, and most of you guys here are in high school, right? So while in college, I was very active on campus. So not only was, I there to study civil engineering, but being active in some of these organizations helped me build some things that, I wasn't really getting in my engineering classes, such as, working in teams and doing a lot of the time management that helps me every day on my everyday things that I do today. So I was also passionate about sustainability. So I joined what we call the Green Team. I was an active member there. I also loved giving back to the community. And for that, I enjoyed the Engineering Without Borders, and we did a couple of projects there. Obviously, I joined the Society of Women Engineers because, it's a nice group where you kind of feel like you fit in, and you find a lot of other women who are kind of going through the same thing you're going. Engineering is, mainly male dominated. And unfortunately, even when I was going to college, there were still some classes where I was still the only female, maybe in that class or in that group. So, just to encourage you guys, even while you're in high school, try to join some other extracurricular activities. It just does a lot of, it adds a lot of skills to you that, you probably, would have never had otherwise. So really encourage that. All right, so to what we're here for, right? Like, what do I do every day? So I'm in the construction industry, but I want to make sure you guys understand what that means, right? So there's a phase of design and there's a phase of construction. Whether you're building a building, you're building a roadway, an airport, a plane, whatever structure you can think of, there's a design phase that happens, and that's part of the engineering design process. You may have heard of that before. And so what happens in my industry in the design phase is that, you have typically an owner who puts together a team of licensed architects, licensed electrical engineers, licensed structural engineers, licensed civil engineers, and they basically put a design, a plan together of what they want to see. So if we're talking about a building, this is where they decide, okay, it's going to be a 3-story building, it's going to have 2 elevators. They make the calculations to figure out the capacities, the loads, whether it's for structural, for electrical, for the HVAC system. That's where all of that happens, right? So what comes out of that is the drawings and the specifications, which are the instructions that I basically get to kind of go through and figure out how to make this actually come to life. So that's where the construction phase starts, right? So I get all these documents and I basically try to figure it out. How do I build this? How do I make this building come to life? Another way to look at it is, some of you may have done Legos in the past. So when you're doing a Lego box, right, you open your Lego box, there's a set of instructions. If you go through that instructions, it tells you step by step, how many materials, what type of colors. And so you kind of segregate those materials, and then you complete step 1, and then you can move to step 2, and then step 3. And then before you know it, you build a whole Lego city, right? Similar to that is what I do, but unfortunately, unlike Legos, the instructions aren't always fully coordinated, right? They don't tell me step 1, 2, and step 3. I kind of have to figure it out. What's the best step to make this structure come to life in the most efficient, time sensitive and budget sensitive way possible, and of course, always in a safety way. So all these things to keep in mind. All right. So just to summarize here, a general process of what the construction process is. So you have your design phase. Sometimes the owner will engage the construction management team earlier on that phase because we bring the experience of, again, the sequencing of how things work, pricing. We understand the cost of how much things are going to cost to build, so we can provide some feedback to the design team on that front. But once that's kind of baked in, then we move into what we call the pre-construction phase, where our estimating team will go through these drawings, these specs, and we'll start putting a number to it, right? So think about, they're looking at things such as, how many bathrooms, how many windows, how many doors, how much square footage of this building is going to have tile or carpet, right? Tile and carpet, those are different price points. So that's what the estimate is, kind of dissecting the entire project and putting a number to how much this is going to cost. And then we have a procurement team. And what they do is basically buy what we call packages. So you have a tile package, right? This is the contractor who does tiling, and they are the experts in tiling. Then we have a roofing package. This is the roofer who's an expert at roofing, and will do the roofing for our project. You can have curtain wall, who focuses on basically the exterior wall of the building. You may have a steel package, or all the steel for the project. Can anyone put on the chat some other packages that we could potentially be buying out for a building? So I mentioned tile, the steel, the roofing. What other packages do you see happening in a building that we would have to procure?
Glass.
Yes, very good. Glass.
Nuts and bolts.
So the nuts and bolts will go with each major trade, right? Like a carpenter, I don't know if you guys put that in the chat, but a carpenter may have some nuts and bolts. The electrical contractor may have some nuts and bolts, but
wires, pipes.
So the wires will go with the electrical contractor. With that package, he would include that. And then for the pipes, that would go with our plumbing package. Our plumbing contractor will include all the piping for the building. Very good. That's great. I'm so proud of you guys. Awesome. So that's a pre-construction phase. So once we bought in our packages, we basically have what we call our trade partners. Now that we have our trade partners on board, we can start mobilizing. And when we mobilize, there's some things that we're responsible for as a construction manager of the project. So I'll start off with schedule. When the owner has an expectation that the project's going to be built in a year, then that's really all we have. At Turner, we have a saying, a promise kept is a promise made. And so we keep that very seriously with, everything that we do. So we committed to making this project happen in a year. We will do absolutely our best to make sure that that happens. We're also looking at the budget. Some owners have plenty of money and they don't mind spending the dollars. They don't mind making the changes throughout the project and adding costs to the budget and the project. That's great, but we still have a commitment to, give you this project for this price, whether it's $1 million, however big the project is. Other projects, especially hospitals, they may have a limited amount of budget because that's what the company allocated for that project. And so regardless of whether they have or not, our commitment is that, we're going to keep that project within budget. So we're looking at budget basically, constantly. Obviously, it's a construction site. That's what we do. So there is some heavy equipment. There's a lot of noise. There's a lot of risk in the everyday work that I do, right? Every day I go to work, I'm wearing my PPE, everything you guys mentioned before. As I'm walking around, I'm always trying to be aware. And so safety is such a big aspect of, what we do every day. One of the things that I try to do, we have an app called Safety Net, where, we try to do some safety inspections. So I train myself to go out there and take a look at what the guys are doing. Maybe someone is cutting something and they're not using their gloves. That could be dangerous. So asking them, to please stop and please wear their gloves. And if they don't have some, maybe provide them with gloves. So there is absolutely no excuse to not be safe on site. That is absolutely important. In some of our projects, we actually have a dedicated team just to focus on safety, right? Then the other thing we look at is the scope, making sure that we're building what, is expected of us to be built, right? So sometimes maybe in the drawings, for example, the architect might have put 3 lights on his drawing, but then I go to the electrical drawings and I see 6 lights. So then it's a question to the owner, to the design team, hey, are we expecting 6 lights in this room or 3 lights in this room? Something as simple as that. Sometimes things are not coordinated, so we want to make sure that the scope is clear and to what's expected of us. Then the quality, right? When we receive things on site, when we're ordering things, making sure that we're ordering the right tile, the right ceiling grid, that the right material, what's been reviewed and approved by the client, by the design team, and even when it's installed, right? Is the caulking all over the place? You know, just even little things like that, making sure that the quality of what we're turning over to the client is what it needs to be. And then last, commissioning. A building is it's a living thing in my eyes. You know, you have lights, you have air, all these MEP systems need to function. And so that's what we do through commissioning, making sure that the equipment and pieces that was put in the building are working to what they need to, that the pressures are correct, that the voltages are right. And so we go through a whole process of commissioning to make sure that we turn over something that is what it needs to be and that it's working. And then the last phase here is the on-air occupancy, which is our project closeout. That's one of the best times of our team. You know, we were so happy when we get to that time when we're able to turn over the project to the client. We see them moving in. And then as part of this project closeout, we also gather some documents for the client when we turn this over to them, such as warranties, operation manuals, so that, you know, when we leave, they also know how to operate different things. We provide training for them. And we also provide them with something called as-builts, which is very important because as-builts basically are the drawings that capture what actually happened during construction. So the architectural drawing may have showed a wall in X location, but when we were demoing, we found a steel that wasn't shown there before, or a piece of pipe that nobody knew was there. And so that maybe caused us to move the wall 3 feet to the left. And so these as-builts would show what actually got built, as opposed to the architectural drawings, which showed, you know, the original intent. So these drawings are very, very important. So this is the sequence of you know, what I do. So one of the things that, here, in summary of, you know, the construction management is a professional service that provides a project owner with effective management of the project. So you're managing the schedule, the cost, or the budget, safety, the scope, the quality, and the function. This picture was taken last year, June 3 of 2022 at 10:45 a.m. And this is actually me. I've just moved, we were a couple months into a project that I was working with. We were building the headquarters for Party City. Yes, the Party City store, the store that you go and buy your balloons and all your party accessories. So they actually moved their headquarters to Woodcliff Lake, and they are tenants in this building. We actually built the building, so it's nice to go back to the space that we built. And as tenants, they're occupying the entire space. It's 209 square feet of space, 3 floors, an underground garage, and we basically fitted out the entire building for them. And this is a picture of me walking with the owner. That's the woman to the right of me, and the owner's rep, the gentleman to the left of me. And this is, you know, we have weekly meetings with the owner to give them, you know, project status basically. And on some of these weekly meetings, actually on all the weekly meetings, we always go for a walk, right? So they can see the progress that's happening on the project. And in some of these walks, we use those walks to either ask for clarity, or sometimes the owner would use that as an opportunity to say, hey, I wanted to move this actually over here, or I wanted to change this, I wanted to change that. So, you know, this is just me having a discussion with them here. All right, so just want to make sure you guys are all awake. So we're going to have a checking time. At this time, if you guys can please get your phones. You can use your phones and your camera to scan the QR code, or copy the URL into a web browser. That's paulev.com/Ruby Lopez 148. And that's going to prompt you to a page where it's going to ask you to put your name. You can put your first name, and it should tell you that, you know, you're waiting for me to basically activate the poll. So bear with me here. Okay. So the poll is asking, what are the responsibilities of a construction manager? So you should be able to type in your answer there and submit. I'm going to give you guys leadership. Okay, schedule, yes. So leadership is a good quality of a manager, right? You want to make sure that you have a good team. But in terms of the responsibilities of a construction manager, you have schedule is a good one, safety, absolutely, cost, collaboration is a side effect of, you know, having a project management team. Everybody needs to work together. The quality is definitely another of our responsibilities. Manage, there you go, facilitate, building, tracking. But I see the bigger ones here, the manage, the budget, the safety, cost, and safety, absolutely. So you guys definitely hit it in the head. I don't see here commissioning. That is part of some of the responsibilities that we have to do here. All right, good. All right, so you guys are not sleeping. I'm glad. Good job. All right, so I'll put this over here. Okay, moving on to the next one. So I talk a lot about the process. Now getting into, you know, as an engineer at Turner, I spend a lot of my time looking at drawings and specifications. You know, a good engineer should really know the drawings and specifications at the back of their head, their hand, because if you're walking around and you know, somebody has a question, the answers are typically there. And so if you're knowledgeable of your drawings, you know where things are, or at least where to find them, that allows you to be able to give people quick answers, right? Like sometimes I'll be walking around and, you know, someone would be, you know, like, oh, hey, I'm trying to coordinate this floor here. Do you know what size the tile is going to be, you know, so that we can make sure that the floor height is correct and things like that. So maybe I don't know the size of the tile right away, but I should know exactly where to go to get that answer for them. So I want to talk to you guys a little bit about drawings and specs, and I really want to get a little bit into it so you guys can get a feel for, you know, what I do every day. So let's start with the drawings. So the drawings are exactly that, right? They're the drawings of the building. They are provided to you from the architect. The architect usually compiles all of the set of drawings, right? And each architect could be a little bit different. So maybe one architect would give you the general plans and the general code in one section. Maybe someone else gives you in two different sections. But generally, this is a good standard way of how we usually get the drawings. So the general code plan, you know, will give you information about, you know, ADA compliance, maybe egress methods for the building. And so that's just your general set of drawings. Then you have your demo drawings. Those drawings will show you what areas of the building or the structure you're working on are going to be removed. So maybe there's an area where a whole wall needs to be demoed. So we'll clearly show that. Or maybe it's just a door that needs to be demoed. So it will show that as well. So as you're looking into, you know, as you're moving towards the demo part of your project, you need to understand, you know, what is going to be demoed and what it's not, especially when you're working in an existing building, obviously. Then you have your architectural drawings. So that you will, you know, they'll show you elevations typically. They'll show you what we call RCP plans, reflected ceiling plans, and that will give you information about, you know, the ceiling type for that floor. Maybe it's a hard ceiling, maybe it's a tile ceiling. It'll give you that information. They also give you schedules, some, for example, door frames and hardware schedule. So you can use that schedule to identify a door in an area and figure it out, is this door, what type of hardware is this door getting? They would also give you a finish schedule. So if you see a PTO1, maybe that's a white. If you see a PTO2, maybe that's a purple. And so it'll just delineate, the acronym and what type of finish that is. So if you see it throughout the architectural drawings, if you see a PTO1, you always know that that's going to be a white paint color, just as an example. Then you have your structural drawings. Those are obviously really important because they dictate and show you the layout of the steel, what size beams you need for your building and how they go. You have your fire protection. So making sure that you account for, all your fire protection equipment, maybe strobe lights, smoke alarms, and things like that. Plumbing, it shows you how your water lines go, cold water, hot water, sewage lines, how all those lines get connected. Then you have your mechanical, so that will show you how your HVAC system is run, what type of HVAC systems you have. They also give you like a schedule that shows you, for example, one HVAC unit in this room, this type, different HVAC unit in this room, in this type. So it'll give you all your HVAC information. And then you have your electrical drawings, right? None of these systems kind of come to life without electricity. That's kind of what brings them to life. So the electrical drawings will show you the power requirements, or, how you're connecting all of these and bringing all these systems to life, how much voltage, the panels, where everything is wired to, basically. So this is just a general breakdown of how we get through the drawings, right? So the drawings are nice, but then you also have the specifications. And this is just a screenshot of of a table of contents of one of my spec books, but it's generally about the same. It starts with a general requirements section. So if you need to know, hey, what do I do if there's a material that's specified in this spec book, but it's no longer available? So they tell you right there that there's a substitution procedure. So you can go into your spec book and read those procedures and understand how to go about presenting that substitution request. There's also closeout procedures. So anything general information they need to know about your project, that would be in your general requirements. And then you go basically almost like package by package, trade by trade, like we talked about. So you have existing conditions, concrete, cast in place concrete. It tells you specifically what type of concrete you must have, the strength of the concrete. If you keep going down on metals, structural frame metals, it tells you all the specifications you need to know for all the different materials that are allowed on this project. So another great resource. Now, if you guys can put in the chat, if can I install a material that's not in the spec book? Yes or no? Can I use a material that's not in the spec book to install? Can I install that material? What are we getting, Mary?
We're getting no, no, no.
Very good. No, 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 no. So if it's not on your spec book, it's not an approved material, unless you've gone through the substitution process, or unless you've submitted and request formal approval on that material and you've gotten approval to use that material, then you definitely absolutely cannot use that, right? And that would be part of the quality control, where any material that arrives to the project site, we will inspect it and make sure that it's exactly what was approved. Typically, especially for finishes, we tend to have control samples on site. So it's easy to take a look at the sample and look at what, arrived to the site and say, hey, this is not what we were supposed to get. The shine's not the same, or, the color is not the same. So we can turn that away and make sure we get the right materials. Okay. There you go. All right, so this is we went high level on the drawings, but let's go a little bit. Let's do a little hard dive into the drawings, right? So this architect actually did something really nice that I appreciate that not a lot of architects do. And basically what they did is they provided elevations, reflected ceiling plans, a dimension plan drawing, all in one for this one area, which is a restroom. Not a lot of architects do that. Sometimes you have to keep going through different pages to try to find where the elevation for this one bathroom is. But this architect actually put it all in one drawing for this one bathroom. So I definitely appreciated that, because now I just have to go to this one drawing to see the bulk of the information. In the next slides, I'm actually going to zoom in the different areas and we're going to go through it. Okay. So this first detail here, so you can see at the bottom, it says 1 A2.3. So we read that as detail 1 A2.3, women's restroom of the house level 1, and it provides us a scale, so we can scale it up if we needed to. And in this drawing, you can see, can you guys see my mouse?
Yes.
Awesome, thank you. So in this drawing, you can see that there are these stalls here. So it's a bathroom, so you can assume that these are the toilets. You also see these right here. That's the way the architects draw doors. So I can see that these are the doors for the stalls. There's also a line, if you see here, for example, a TO2. So if I go to that architectural finish plan that I mentioned, I'm going to see that TO2 is a type of tile, and it will tell me exactly what type of tile goes here. And the fact that this is drawn from this point to that point means that this entire wall gets that type of tile, TO2. But then on the same token, you see that there's another arrow here, and it says WC01. WC is wall covering. So what this is telling me is that this bathroom has this wall and this wall with wall covering, and this back wall is all tile, which is typical for, a bathroom. You have tile. Having the wall covering is a little bit fancy. This is actually a theater, so they really went up there. It was nice. Some other things to call your attention to. So you have different types of tile in here, and you see that because, again, the tag that is to the element here, you have T11, T13. It's just a different types of tile and dimensions. I actually have a picture of what this looks like. So in real life, so you'll get to compare the drawing, right, how we did from the drawing to actually getting it built out. So I'll show you guys that in a minute. Some other things to look over here. There are these things here. These are the sinks. And can you guys put in the chat what type of tile goes in the back wall of the sinks? What's that tile name?
TO4.
Oh my gosh, look at you guys. Yes, TO4 is correct. All right. The last thing I want to just bring to your attention is this stall right here is larger than these, and that's because it's an ADA stall. And as you do more of these jobs, you get to learn a lot about ADA and making sure that we comply with those. But that's why this one's larger. So that means that a person in a wheelchair can actually use this bathroom, and it's wide enough. It has the rotation required for the wheelchair. Okay. The other thing I want to call to your attention is this right here, right? So what does that mean? Whenever you see the symbol, what that means is that if I go to the drawing A2.3 and I go to detail number 6, I'm going to be able to see this elevation. We're going to go there in a minute so you guys can see. But this elevation, and if I go to this elevation, I should be able to see the stalls, right? The bathroom stalls. So if I go to this elevation, it's going to be nice because maybe I can see the height, how tall are these, and just see, the elevation that I can't see from a plan view. And then on the same hand, if you go to drawing A2.3, but you go to elevation 2, then you should be able to see what's on this side, right? That's where the arrow is pointing. So you will be able to see the sinks, more information on the sinks, what's on these walls. Because right now we can't really see. We see that there's sinks in here, but we don't know, are there mirrors? Are there lights? What else is on this wall? We can't see that. So we'll need to go to this elevation to see that. All right, so just remember that. So 6 is going to show us the stalls, and 2 will show us the sinks. We'll go there in a minute. Okay, the other drawing that they provided was a dimension plan. And the nice thing about this one is that it actually provided us with dimensions. Typically, architects provide dimensions when they, absolutely need to hold that dimension sometimes. So for example, here, they're giving us an EQ, which means equidistant. So what they're saying is, we know that there's this space, you know, let's try to make the best that we can do to keep them equidistant from each other. So, and keep that throughout. This bathroom here is saying that, you know, we need a minimum three feet. So we know that, you know, in the field, we would take this dimension, we would take the 3 feet minimum, and then the remaining, we can make that be equal, right? Because at least we need to make this to be 3 feet. Some things to keep in mind. The other thing here is you see this bubble here, RFI50. RFI stands for request for information. So whenever there's a question about something, whenever something is not clear, we submit what we call is an RFI, a request for information. And in this case, we asked the question to the design team, like, hey, there's no paper towel dispensers in this bathroom. Like, don't we, you know, other bathrooms have it. Don't we need one in this bathroom? And so the answer was like, oh, yes, please add 2 toilet paper towel dispensers. And so they revise this sheet, and anytime they revise it, what they do is they add these bubbles in here. And so the response to the RFI was add 2 PTD R in this room. And so if I go to another drawing that kind of gives me the legend for the project, and I look for PTD/R, I know that what they're referring to is a combination towel dispenser and receptacle, which means that it's a paper towel dispenser that comes with almost like a trash can that you can throw the paper towel in. And so that was important, because if I didn't read this, right, maybe I would have missed it and just say, oh, they want a PTD, they want a paper towel dispenser. Well, that's different than a PTD/R. So very important to understand what the acronyms are. Most of the time, the acronyms are relatively the same throughout all the projects. Most of the architects use the same acronyms, right? Like EQ is going to be EQ everywhere. But PTD/R, this was actually the first time I've seen it that way. So there might be some nuances here and there. And so that's where this is where they were added. So if you can see, this is the bubble, and you can see that they were added here. If you go to the drawing before, it wasn't there. Okay. Another architectural plan here is the RCP. I think I mentioned it before. Do you guys remember what RCP stands for? Can you guys put it on the chat if you guys remember? Starts with reflected.
Nobody's answering.
It's okay. I think I said it real quick. So RCP stands for reflected ceiling plan. And this is the drawing that shows us what's happening at the ceiling level, right? Is it a hard ceiling? Is it a suspended grid ceiling? And so here, if I go to a legend for finishes, it will show me that if I see a ceiling that has these dots everywhere, that's a hard ceiling. So this bathroom, the entire bathroom, from what you can see, is getting hard ceiling. So it's not suspended, it's all hard ceiling. The reflected ceiling plan is also showing me lights. So these circles here are some of the light fixtures, and you can see here the legend that they provided shows light fixtures. So 1, 2, 3, 4, 5 light fixtures. And then it also shows maybe sometimes I'll show you like sprinkler heads if you need them in the room. It also here, this dimension here, 8 foot, means that's the height of that ceiling. So that means that that if you measure from the floor to the bottom of the ceiling, you should be at 8 feet. So that's great information to know how high, how low we need to go, right? Some rooms maybe need to be taller. Some other rooms, you know, maybe need to be higher. 8 feet is pretty standard. All right. Okay. And now we have elevations. I love elevations because it kind of helps you put things into perspective. It's a little bit easier to see. So you guys remember how in the drawing before we had, you know, go to A2.3 elevation 6 to see the stalls. Well, here we are. So here we see all the stalls on that side. It was the top side of the drawing. And then elevation 2 was supposed to show us the south side of that drawing, which were the sinks. So now that we see this elevation, we can better see that there are these mirrors that go into this wall, and there's also tile that goes into this wall. And we see these light fixtures that are going in the wall as well. So we also see that this sink or this countertop here has some sort of metal mesh at the bottom. And this is something, again, that we wouldn't have been able to see if we were just looking at the plans. So looking at the elevation gives us more detail of what else goes into this building, into this construction here. The fact that these are X here means that it's open, so it's just an entrance. TPO3, that's a type of paint. I'm sorry, that's a type of stall. So all these stalls are TPO3 type stalls. And we would go to either the finished plan or the specs to know specifically what manufacturer, what type is TPO3, what exactly that is. All right. Okay, so so here is a picture, if you guys remember, of that same drawing, but this is what actually got built from that drawing, right? So you guys remember there was a lot of different call outs for the different tiles. And so that was because you have this white tile, you have this gray tile, and they were called out differently because it's different color. They're also called out differently from this tile because it's a different size. So the architect did a really good job on making sure that we identified all the different pieces and make sure that we realized that they were all different. Can you guys see the PTD/R in this picture? You can chat yes or no. I hope you guys can see it. But if you can't, this is what it is. So you have your paper towel dispenser and your receptacle here. So you can take the paper towel, dry your hands, and dump it in there. You also see here your sinks. You can see your tile. In the light fixtures that were shown on the drawing. If you guys remember, these are the lights that we saw on the reflected ceiling plans. We counted like 6 of them, I think, which corresponds to our 6 sinks. And then these are the stalls. So if I just kind of go back real quick.
So Ruby, we did get a wow, and oops, I just lost the other one, but a lot of complimentary messages.
Someone said it was slay, so.
Oh, very good. Great. So, you know, just going back, you know, you can kind of now that you've seen the real picture, you know, what the vision was, right? Going back to your drawings, you can see, you know, that the architect did a good job at, you know, really capturing what they wanted for this bathroom, for this space, from, you know, indicating exactly how these doors were going to more or less look like. Even the tile, right? They show this tile in this pattern, and the light fixtures really closely match what we actually got and what we actually installed. So you know, overall, it's just always nice to go back to the drawing and look at, you know, what you built and say, wow, you know, this looks great.
We did get one question of were some of these drawings made with AutoCAD? You'd mentioned that the architect did those. Do you know?
Yeah, so the architect does put the drawings together, and they are generally done in AutoCAD. Usually all the architects, even the MEP engineers, mechanical, electrical, and plumbing, they all use AutoCAD. I remember doing an internship with a civil engineering design firm, and that's where I learned a little bit of CAD because that's all they used. So, so yes, to answer your question. All right, very good. All right, check-in time. So I think we have like 15 more minutes. So at this time, I believe the team sent you guys a drawing. If you guys can pull up that drawing, it would be great if you can zoom in and zoom out, because I have some questions for you to make sure that you guys, you know, see if you guys learn a little something here today.
Annalise just put that in the chat. So if you don't have the drawing from the email, you can go to the chat and open it up there.
Awesome. That's great.
Does everybody have access to the drawing? Give me a thumbs up. Okay, we're getting a yes. Yep, okay, we're getting yeses. Great.
Awesome. So, so right now we basically dissected one of the bathrooms, right? We went through all the different little drawings and nuances from the bathrooms. That was the women's bathroom. The drawing that you have is LO1 men's room. So you're looking at a men's room. And so I have a couple questions to see if you guys can identify it from your drawing. So the first question, how many sinks are in that men's bathroom? If you guys can put it on the chat.
Three. Lots of people saying 3.
Very good. The answer is 3. Awesome. Good job. All right. Number 2. How many stalls are in this bathroom?
Okay, we're starting to get 3s. 3.
3. Survey says 3. Very good. So far, so good. Next question. What type of tile goes on the wall by the sinks? Is it a TLO1, TLO2, TLO3, TLO4?
04, TO4, TO4, TO4.
All right, very good. Next question. How many sprinkler heads are in the bathroom? So I don't think I think I missed that one on the other drawing, but those are the dark circles. Those are considered your sprinkler heads. And that's what basically, you know, God forbid, in case of a fire, they go off and they release water.
We're getting 4. Somebody said 3. 4.
Okay.
4.
So 3 was the answer.
Ooh.
You might have been seeing an extra light fixture there or something. Good job for those of you who said 3. All right, number 5. What is the symbol for a mirror? So just like T-O number is a symbol for tile, what is the symbol for a mirror?
MR2, MR. Lots of MRs.
Absolutely. Good. So in this project, they chose the MR as a symbol for mirrors. 2 is the designation of that specific mirror. There was MR1, which is a different type, different size of mirror. So in this bathroom, they specify MR2. So we said MR, that's great. If you said MR2, that's very specific. That's awesome. All right. Oh, and that's it, guys. Well, thank you guys for having me. I hope, you know, you guys were able to learn something and you enjoyed, you know, walking through me on a daily day as an engineer at Turner, going through the drawings and the specs and, you know, going through coordination. Thank you.
Yeah, everybody like give some snaps, claps, throw a bunch, throw stuff in the chat for Ruby. This was such a great session. I honestly think it's been one of my favorites that we've seen this whole SHLA year. We have a little bit of time for like some Q&A. So maybe we take a few minutes to do that. If anybody has any questions, go ahead and throw them in the chat, or you can raise your hand. Yeah, so go ahead and start putting those in. And then if for some reason we run out of time to get anybody's questions answered, as always, you can always put them in the Slack channel or email outreach@SWE.org and we will send them to Ruby. So put any questions you got in the chat.
Awesome. So while you guys put those questions, just like another thing that we do is virtual construction. I didn't talk much about that, but just like you guys saw going through the drawing, sometimes, you know, you don't really see everything, especially when you're trying to coordinate MEP systems and you're putting pipes and you have just a little bit of room in that ceiling. How do we make sure that all the pipes that need to go there fit? That's where our design and construction team comes in, where we actually model the building and basically do the construction in a model. So this helps us a lot because when we do it in the model, we can be more precise with, the height and location, and we can see when we have hits, we can see, hey, the steel is hitting this pipe, so we're not going to be able to construct it that way. We have to shift the pipe, and we can get those going on those discussions beforehand. It's also beneficial to do virtual construction before, actually building it there. For hospitals, and we've done that also in one of my first projects at Turner. We were building a cancer hospital, and being able to allow the nurses and the doctors to wear the goggles and virtually walk through that room, that surgical room, for them to have the ability to say, hey, this piece of equipment, it's not where I need it to be. I need it to be closer, or I need it to be further away. I'm not going to be able to do surgery properly like this. So we've seen that brings a lot of benefits because it avoids changes down the road, which are obviously more costly once we start going into construction. So that's another big aspect of where we're kind of heading into, is not just going out there looking at your specs, your drawings, and building, but it's all this effort and coordination to make sure that we look at all the clashes, and we save everybody time and money and build what we need to build. So if anyone's interested in that, it's called Virtual Design and Construction, BDC.
Amazing. I think people might either be like thinking of some questions, but I'll ask one. What kind of, I just with all of like the drawings, and there's so many symbols that it seems like you have to kind of like picking up a second language to be able to look at these drawings and kind of know what you're looking at. What kind of courses like specifically did you end up taking in school, and like was there like a specific learning curve to learning how to read these drawings and know what everything means?
So in engineering school, the first year, all engineering major students are taking the same classes. So my freshman year as an engineering student, whether I was civil, electrical, mechanical, chemical, we're all taking the same engineering classes, math, chemistry, all of that. And one of the required classes as an engineer student is this SolidWorks class. Some universities give you CAD. At Stevens, we got SolidWorks, and through SolidWorks, it's similar to CAD where you get to model different things. It's more mechanical driven for mechanical systems, but you get to learn a lot about sections and elevations and cut sheets and blowouts. So that class really helped me better understand, when I'm looking at an elevation and when I'm looking at a cross section of a drawing, what am I looking at? what exactly am I looking at? That definitely helped. The other thing, just in general, once I got to my second, third, fourth year, and now I'm more, focused on specialized civil engineering classes. Actually, the first 2 years are pretty generalist, 2 and 3, 3 and 4 that are more specific to your major. But I think just in general, like all these engineering classes really taught me to problem solve. Every year there's an engineering design class, right? Every year. Freshman year, it was building a robot that went from one side to the other. The second year, I think it was building a truss that could withstand, could buckle in the least amount of time, meaning it's strong. And so on. And so every year was a different engineering design. So you learn to work in teams, you learn to problem solve. And that's huge with engineering, right? Because you're constantly problem solving, whether you're doing engineering in the design side, you're problem solving, doing the calculations. If it's not coming out right, what are we doing? Do we increase the pipe? Do we reduce the pipe? If you're designing a rocket ship, same thing. There's a lot of design and problem solving that goes with it. And same thing with what I do every day in construction. Maybe there's a detail that the architect wants that, it's not really feasible. How do we make this detail happen? How do we make this detail come to life? Maybe not exactly how they want it, but something similar, something close. So I think in general, our engineer will tell you that what they got most about college is probably that problem solving skill. You're constantly problem solving every day.
What do you love most about your job, Ruby?
I one, I really love, I love the culture. You know, it's really nice and refreshing to go to work every day and, you know, being surrounded by people who think like you, right? Everybody's really passionate about the work that we do. And so that's really refreshing. But then also knowing that at the end of the day, I'm going to walk away from this project and I'm going to really make an impact on someone else's life, right? Like my first project, building that cancer hospital, was just so remarkable, right? I spent 3 years of my first year with Turner on this one project from beginning to end. I was one of the last people walking out of that project. And as I was leaving, you know, I saw patients coming in, people in wheelchairs coming to get chemo, coming to get treated. And so knowing that, you know, it was a lot, it was challenging. I learned a lot of things, but at the end of the day, you know, this building was going to help a lot of people. It's definitely very rewarding. It's really nice to also walk around and say, hey, I worked on that building, or oh, I did that building. So that's really cool.
We did get a question. The question was, did you ever second guess yourself? Uh-oh, I just lost the question. Annalise, do you see it? Yeah.
Yeah. This question, Jada asked, did you ever second guess yourself while you were in college in male-dominated classes?
So there was a time, you know, freshman year was really difficult for me. I going through that transition from high school to college, you know, was a little bit of a struggle. I was an honor student and the valedictorian on my high school. So I'm coming into college, you know, thinking that I know everything. But the reality was that there were people out there who knew far more than I did. And so, you know, not doing well that freshman year really hit home. You know, I'm so used to getting A's and B's, and now here I have a C, and, you know, it was really shocking for me. And so that was a point in time where I kind of reconsider and say, hey, is this even for me? Am I smart enough to pursue engineering and go through this career? But my dad, you know, he's always been a pillar behind me and supporting me. And he said, you know, you can do anything you want, just be the best you can be and work hard at it and you'll succeed. And so the next year I came back and I did. I went to tutoring. I woke up earlier, went to the library, you know, studied more, studied harder. And, you know, next thing I know, you know, 4 years flew by and I'm graduating. So it was good. But in terms of, so that was the only time I might have double guessed myself because of that transition. But, you know, once you get the hang of it, it's just, you just don't even think about it. You just keep going. And next thing you know, you're graduating. But in terms of being a male dominated field, you know, I was lucky that my dad always encouraged me and he never, you know, made me feel like, hey, you're a girl, you can't do this. On the contrary, you know, when I was in teams where I was the only female, it encouraged me because, you know, I had the ability to try to help and coordinate. And sometimes, you know, my partners, you know, they had all these different ideas, but they just couldn't get it together. Like I'm very structured and, you know, methodical. So I was able to bring that to the team and, you know, we did some really cool projects. So thankfully, I, you know, not in that situation. Even in the construction industry, I know when, you know, I was graduating, there's the design path and there's a construction management path. Some of my classmates really questioned me about, hey, are you sure you want to do construction management? Don't you want to go into design? And I said, well, why wouldn't I be able to go to construction management? And, you know, they said, well, you know, you're soft-spoken, you're petite, like, you know, that's a male-dominated field. You know, guys are like screaming and yelling out there. And I'm just like, no, I'm definitely up for the challenge. But I have not, you know, encountered that everyone. And that's another aspect of Turner that I love is the culture. There's you know, there's a lot of, you know, good culture in the company, and we move that across our projects, you know, where we really foster respect and taking care of one each other. So when our trade partners are on site, you know, they're not less than me, they're not more than me, they're partners to me. And so that's how we treat each other. So I've never felt disrespected by anyone. I've, you know, never, you know, felt like, oh, because I'm a woman, I can't do this. On the contrary, I get a lot of respect from my team. And that also pushes me to work hard and to make sure that, you know, I know what I'm talking about. So, you know, people would respect me. I think you're muted.
Thank you.
Yeah.
I was just saying, really, really amazing session, and I'm glad you got to answer like these questions. If anybody has any questions that you think of after this session is over, like I said, you can send them in the Slack or email them to outreach@SWE.org, and we'll pass them along to Ruby. I think we're at 7:30, so I think we'll move into thanking our sponsors one more time. I want to give a shout out to Amateur Radio and Digital Communications, Danaher Corporation, General Motors, and a big special thank you to Turner Construction. And then I think can move to the SHLA updates page. Perfect. Thanks to you guys for coming to this session. I hope you enjoyed it as much as I did. I thought it was so interesting to see all of the drawings and, so much of what you are going and buildings you go into every day. Like, this is the stuff that goes into it. So it's really interesting and crazy to think about. Just as a reminder, you guys have a SWENext Connect, the college readiness one coming up next. I think that's either next week or the week after.
It's next week on Monday, the 24th, and I hope you'll join us. We'll have SWE members there to act as mentors and explain some of their college readiness, how they got ready for college, and answer your questions.
Yeah, and I'll send out a reminder about that too for you guys later this week. And just a reminder, all of these sessions are put on demand on the SWENext YouTube page, and all of those links are in the SHLA resource document with all of those links. But as always, you got any questions, you can email the outreach@SWE.org email, and we'll answer any of your questions that you guys have. Yeah, and you guys can sign up to be SWENext influencers or start or join your own SWENext clubs. And you can find all of that information on our website or email us any questions that you have. But that pretty much wraps up this session for tonight. Thank you everybody who joined. Thank you so much, Ruby, and I hope everybody has a really good evening. Thanks so much.
Thank you, everyone. It was nice speaking to all of you. Have a good night.